Okay, today we're going to talk about the distributive property as well as simplifying algebraic expressions. So first with the distributive property, we come on down here to the active vocabulary section. It says write the term next to each definition. So the first definition, to find the value of an expression, that is to evaluate. We don't solve expressions because there's no equal sign. We evaluate them when we plug the numbers in. The second one, the rules that let you know which operations to perform, that's the order of operations. So we use order of operations after we've plugged in while we're evaluating expressions. Okay, define simplest form in your own words. In the diagram, underline the coefficient. The coefficient here is 10. So coefficient is the number that goes in front of the variable. On some of the challenges you may have gotten back, you may have seen something that said not proper math grammar. So to write y10 like this, not proper math grammar. The coefficient should always be in front of the variable, not behind it. So this right there, that's not proper math grammar. Again, the coefficient goes in front, not behind. All right, now define in simplest form in your own words. Simplest form is when all parentheses are removed and all like terms are combined. And we're going to learn more about what like terms means in the lesson after this one. All right, vocabulary link. Distribute is a word that is used in everyday English. Find the definition of distribute using a dictionary. Explain how the English definition can help you remember how distribute is used in math. So the word distribute means to pass out, and not pass out like faint, but pass out like to pass out papers or to pass out candy on Halloween. You're distributing papers or you're distributing candy. In math, we distribute the number outside the parentheses to the numbers inside the parentheses using multiplication. So if we had A on the outside and B plus C on the inside, we distribute A to B using multiplication and A to C using multiplication. So this becomes A times B plus A times C. Moving on to the next page, evaluating an expression. It says Caitlin works at Dairy Whiz Monday through Friday. She earns $8.25 per hour. The hours she worked this week are shown in the table below. Write two equivalent ways of finding her weekly pay. So the first way is to take the hourly rate of pay times the total number for the week. So the hourly rate is 8.25. That's what it says in the word problem, $8.25 per hour, $8.25 per hour. Total means add up all the hours. So 3 plus 2 plus 1.5 plus 4 plus 1.5. And order of operations says that we need to add up all of these numbers first and then multiply. So if we add up all those numbers, we have 8.25 times 3 plus 2 is 5, plus 4 is 9, and then we have 10, 11, 12. So we have 8.25 times 12. Again, we can do this really simply. We do 3 plus 2 is 5, plus 4 is 9, 10, 11, and then a half and a half make a whole, which makes 12. So 8.25 times 12 gives us $99, so she should make $99. Method 2 says take the hourly rate of pay times the daily hours worked, and then we would add them all up. So I'm going to start this way over here. We have 8.25 times 3 plus 8.25 times 2 plus 8.25 times 1.5 plus 8.25 times 4 plus 8.25 times 1 1/2. All right, so we have each day. This is Monday's amount of money. This is Tuesday's amount of money, Wednesday's amount of money, Thursday's amount of money, and Friday's amount of money. So we start at the beginning. 8.25 times 3 gives us $24.75 earned on Monday. On Tuesday, 8.25 times 2, she earns $16.50. Plus, on Wednesday, 8.25 times 1.5 gives us 12.375. Plus, on Thursday, 8.25 times 4 gives us $33. And on Friday, we already did the same. That's going to be 8.25 times 1/2, which was 12.375. So now we can add all those all together. So we have 24.75 plus 16.50 plus 12.375 plus 33 plus, oops, I did something wrong on my calculator. Let's try this again. 24.75 plus 16.5. Darn, that's twice. All right, 24.75 plus 16.5 plus 12.375 plus 33 plus 12.375, and we get $99, as we should. So notice here, this is an example of the distributive property because we take 8.25 and we distribute it out to each one of the numbers in the parentheses, and we end up with this expression right here. All right, simplify expressions. It says model the expression for parentheses x plus 3 by drawing or using algebra tiles, so then simplify. So we haven't really talked a whole lot about algebra tiles, so we can introduce them really quick. We see this long bar, looks like this. Okay, the length is, or the width is 1 and the length is x, so the area is x. So that long bar represents x. Little units look like this, and they're 1 by 1, so the area is 1. So every time we see one of those, it represents 1. So if we have 4 times the group of x plus 3, so we're going to draw the group x plus 3, and we have that group 4 times. So that's one group. Here's 2, here's 3, and here's 4. So then we just count up all our x's. We have 1, 2, 3, 4 x's. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 units. And that gives us 4x plus 12. Same thing if we had used the distributive property. So to do this algebraically, we have 4 times x plus 3. We would pass the 4 out to the x and the 4 out to the 3. So it would be 4 times x plus 4 times 3 is 12. And they match. Helping you remember, write one example of evaluating an algebraic expression and explain how you simplified it. So I want you guys to do this on your own. That way they're not all the same. So write a problem that would help you remember what evaluating expressions means. You can pause the video at this time to do that. All right, so now we're going to turn over to the next section, the next part of this video. And this one is about simplifying algebraic expressions and most specifically combining like terms. And I told you we would get back to what like terms meant. Okay, like usual, we're going to skip the preview and we're going to go right into the lesson. So we have some new vocabulary. Coefficient we already talked about. We said that the coefficient was the numerical part of a term that contains a variable, and it always shows up first. So coefficient matches with that guy, and it should always go before the variable. So if we had negative 2x, negative 2 is the coefficient. Okay, a constant. The constant is a term without a variable. It doesn't change. A constant is also a number. So for example, in the expression x plus 8, 8 is the constant. 8 doesn't change. It's always going to be 8. So something that's constant is something that doesn't change. Like terms. These are terms that contain the same variable to the same power. So we needed to add a little bit there. So for example, 3x, 5x, negative 8x, and 10x are like terms. If you had 3y and 5y, those are not like terms. Or 3x and 5y. Those are not like terms. They have different variables. So those would not be like terms. If you have 3x and 3x squared, those are not like terms because they have different exponents. So those aren't going to count either. Okay? Simplest form. Each part of an algebraic expression is separated by a plus and minus sign. There are no parentheses, and there's no multiplication or division to be done. So simplest form, this is another definition. We wrote the definition of simplest form on the page before. Okay, here's another way to think about it. Simplifying the expression. Let's see. Oh, whoops. I totally just did that wrong. So you want to erase that last line. There it is, an algebraic expression that has no like terms and no parentheses. So we're going to actually make this one go to here. Sorry about that. Last one, simplifying the expression. Okay, make sure that each part of the algebraic expression is simplified by, separated by a plus or a minus sign. So I am definitely not perfect when it comes to math, and I make mistakes. I'm still learning, and I obviously didn't read that close enough. So again, coefficient should go with the numerical part of a term that contains a variable. Constant should go with a term without a variable. Like terms are terms that contain the same variables to the same power. Simplest form, an algebraic expression that has no terms and no parentheses. And simplifying the expression, each part of the algebraic expression is separated by plus and or minus signs. Okay, hopefully you got that figured out. And we're going to go on to the next section over here, and where it talks about parts of an algebraic expression. So we're identifying the parts of the algebraic expression below. How many terms are in the expression? Well, terms are anything that's separated by a plus or minus sign. So 4x is a term, 9y is a term, 7y is a term, negative 2x is a term, and 5 is a term. So we have 1, 2, 3, 4, 5 terms. So terms are separated by plus or minus. How many sets of like terms are there? Well, we've got 4x and a minus 2x, that's one set, and we have a 9y and a 7y, so there's a second set. So there are two sets. 5 is a constant, so that doesn't go in the set of like terms. Circle one pair of like terms. Okay, so one pair of like terms would be a 4x and a negative 2x. You want to make sure you grab that minus sign. So circle one pair, we just did. We can list them here, 4x, negative 2x. List another pair of like terms. We have 9y and 7y. And what is the constant term? The constant term is 5 because there's nothing attached to it. All right, moving on down. Simplify each expression by combining like terms. 4x and 3x, so all we have to do is add their coefficients. So 4x plus 3x gives us 7x. Okay, in this problem, our like terms are the y's. So we have a 4y and a 6y. That gives us 10y. So we have 10, right, from our constant here, plus 10y. Question number 13. We have some a's. We have 15a and 2a. And then I like to draw a different shape around the different variable. We have 6b and negative 3b. So 15a and 2a gives us 17a, and 6b and negative 3b. If we add negative 6, if we add 6 and negative 3, we get 3. So simplified, 15 plus 2 gives us 17a, 6 minus 3, or 6 plus negative 3 gives us 3. Question number 4. We've got 3t is a like term with 8t, so 3 plus 8 is 11. So we have 11t. And then we have a 1 constant and a minus 6 constant. So 1 and negative 6 together gives us negative 5 or minus 5. Last but not least, question 20. We have a 2m. We have a minus 8m, so that gives us 6 negative. So negative 6m. We have a negative 4k, but nothing to combine that with, so it just stays minus 4k. And then we have the constants 3 and 2. 3 plus 2 is 5. Helping you remember, constant is a word used every day in English as well as in mathematics. Write the definition of constant. Explain how the English definition can help you remember how constant is used in mathematics. So the word constant, and this is also used in science too, a constant in an experiment is something that doesn't change. And in math, constant refers to a number whose value never changes. So for example, 8 is always 8. It never takes on another value. It can never be 9. 8 can never equal 9 or 10 or negative 1. All right, that's all for today. Have a good evening, and I'll see you in class tomorrow.